Hello students, today we'll be further studying other distillation method, and that is vacuum distillation. Myself Prachi Joshi from Department of Pharmaceutical Technology. Now, vacuum distillation is also known as distillation under reduced pressure. Now, vacuum distillation process is in which the liquid is distilled at a temperature lower than its boiling point by the application of vacuum. Correct? Now, by this what we are doing? Vacuum pumps, suction pumps are attached to the simple distillation assembly like this. See. Everything else is same. Only thing is here vacuum pump is applied and this flask has only two outings, or you can say two openings. Correct? Other than that, the base is same. Even this is same as that of simple distillation, large scale assembly. Okay. Only difference is here twin vacuum pump is there. Now, vacuum pumps, suction pumps, etc. are used to reduce the pressure on the surface of the liquid. Distillation under the reduced pressure is based on the principle of simple distillation with some modifications. Now, what is the principle? Liquid boils when vapor pressure is equal to the atmospheric pressure. This is the basic logic and this is the base of distillation. Vapor pressure equal to atmospheric pressure, it will boil the liquid. Okay. If external pressure is reduced by applying vacuum, external pressure, now what is the external pressure? The atmospheric pressure. If that is reduced, what will happen? Ultimately, the liquid will have the lower boiling point. Correct? Therefore, see, the boiling point of the liquid is lowered. Okay. Therefore, the liquid boils at lower temperature. Fine. What it tells? Atmospheric pressure is equal to vapor pressure. If these two are same, the liquid starts boiling. Now, what happens is, if you are reducing the external pressure, you are reducing the atmospheric pressure, ultimately what will happen? The boiling point of the liquid will get lowered automatically, correct? Because the vapor pressure would also get decreased by that. So, let's take an example of water. Water boils at 100 degrees Celsius at an atmospheric pressure of 101.31 kilopascal, that is 76 mmHg. Okay, at 40 degrees Celsius, the vapor pressure of the water becomes 9.33 kilopascal, that is approximately 70 mmHg. Hence, the external pressure is reduced to 9.33 kilopascal. Okay, because the vapor pressure should equal to external pressure, that is you can say atmospheric pressure. If these two are same, then liquid will start boiling. Correct? Where the water boils at 40 degrees Celsius. So ultimately there is increase in rate of mass transfer into vapor. Correct? So ultimately vapor will increase. Okay. So according to this formula, mass of vapor, the vapor formed, okay, is directly proportional to vapor pressure of the liquid upon external pressure, that is atmospheric pressure. Now, according to this formula, water is allowed to evaporate at 40 degrees Celsius and 9.33 kilopascal, that is 70 mmHg pressure. Okay. Again, I will explain this part. Suppose, let's take the example of water. Water boils at 100 degrees Celsius, correct? So, what will be the atmospheric pressure? 760 mmHg, that is 101.31 kilopascal. Okay. So, now let us reduce the pressure Okay, the atmospheric pressure, or you can say let us reduce the temperature. How the temperature will get reduced? By reducing the atmospheric pressure, or you can say external pressure. So let's bring it to 40 degrees Celsius. From 100 degree we brought it to 40 degrees Celsius. So if this is getting reduced, ultimately vapor pressure will also get reduced from this to this. See, from 101.31 it got reduced to 9.33 kilopascal. So ultimately, if this vapor pressure is reduced, this will be same as that of the atmospheric pressure. Vapor pressure is equal to atmospheric pressure will boil the liquid. So if vapor pressure is 9.33, atmospheric pressure would be again 9.33. Okay. So the water will boil at 40 degrees Celsius. Fine. So ultimately there would be increase in mass transfer of into vapor. Mass transfer means what? The vapor from the liquid will pass into the vapor phase. Okay. Now this is the construction. It is almost same. Okay. There is capillary tube, cleanse-in flask, water bath, or you can say heater, thermometer is attached into the different opening. There are two openings of it. Okay. Other than that, everything is same. Inlet and outlet of water in the opposite direction of the vapor. Vacuum pump is attached and there is receiver. This is made of stainless steel and only there is a window provided to observe the distillation. Okay. Now see, construction. It consists of double neck distillation flask known as cleanse-in flask. See, double neck. There is two neck. So it is known as cleanse-in flask. Okay. Thick walled glass apparatus with interchangeable standard glass joints are used for vacuum distillation. In one of the neck of the cleanse-in flask, a thermometer is fitted. This. The second neck prevents flashing of the volatility, or you can say volatile agitated liquid. Sorry, violently agitated liquid. That means there is bumping of liquid is there. Bumping occurs readily during vacuum distillation. Now what is the meaning of bumping? Vigorous or violent boiling of the liquid, which sometimes what happens is it may come out of the flask. So to prevent that, we attach placing a fine capillary tube in the second neck of the flask can prevent the bumping. Okay, the capillary tube is dipped in the boiling liquid so that a stream of air bubble is drawn out. Okay, here see this will prevent the bumping, or extreme or violent boiling of liquid will be prevented. Water bath or oil bath is used for heating. Cleanse-in flask is connected to the receiver through a condenser. Vacuum pump is attached through an adapter to the receiver. A small pressure gauge, that is manometer, should be inserted between the pump and the receiver. Here there is a manometer arrangement which is attached, which can measure the pressure. How much pressure is exerted is measured. Okay, working. Now, same as that of the simple distillation method. Liquid to be distilled is filled 1/2 or 2/3 in the cleanse-in flask. Okay. Add porcelain pieces to prevent bumping. If in case the capillary is attached, it is fine. Or you can also put porcelain pieces into it. Now, thermometer and capillary tube are placed in the cleanse-in flask. Vacuum is applied and content is heated gradually. Temperature rises and gets vaporized rapidly due to vacuum. The vapor passes through the condenser and condensate is collected in the receiver. Now let me explain through figure. Now here the flask is filled same as that of simple distillation method. One half or to 2/3 it is filled. There is attachment of thermometer and this pipe that is also known as capillary tube, so that to prevent bumping. So what happens is when the vacuum is applied, what will happen? Due to this vacuum pump, the vacuum would be there, so the boiling point of this liquid get reduced, and at the lower temperature this liquid starts boiling, and because of this the vapor will be formed. It will pass from here and vapor will be converted into liquid by the condenser, through the condenser, by passing of water in the opposite direction. Now when it comes over here, it will form liquid, and liquid is collected into the receiver. Okay. Let me explain you again in Gujarati also. Now આપણે આ ફ્લાસ્ક છે, that is known as cleansing flask, એને 1/3 or 2/3 ભરવાનું, જેવી રીતે સેમ આપણે સિમ્પલ ડિસ્ટિલેશન મેથડમાં આપણે ભરતા હતા. આની અંદર બે it is double necked. ઓકે, એકની અંદર capillary tube મૂકવામાં આવે છે. It is inserted up to this level so that બમ્પિંગ ના થાય. ના વોટ ઇઝ ધ મિનિંગ ઓફ બમ્પિંગ? બહુ વધારે બમ્પિંગ થાય તો લિક્વિડ બહાર આવી જાય, તો ઇન બોઇલ થાય, તો એટલે આપણે એક ટ્યુબ નાખીએ છીએ કે બમ્પ ના થાય, વધારે સ્ટેબલ રહે અને બહાર ના આવે લિક્વિડ. પછી અહીંયા શું થશે? તમે અહીંયા વેક્યુમ પંપ છે, સક્શન પંપ છે, એનાથી તમે સપોઝ આ લિક્વિડનું બોઇલિંગ પોઈન્ટ છે 290 ડિગ્રી સેલ્સિયસ. ઓકે, હવે 290 પર આવતા આવતા એ ડિકમ્પોઝ થઈ જાય છે. હવે આપણે વેક્યુમ પંપથી આપણે શું કરીશું? એનું પ્રેશર રિડ્યુસ કરી દઈશું. જેવું પ્રેશર રિડ્યુસ કરીશું, ટેમ્પરેચર રિડ્યુસ થઈ જશે. કેમ રિડ્યુસ થશે? કારણ કે ટેમ્પરેચર અને પ્રેશર હેઝ અ direct relationship with each other. They are both directly proportional to each other. So pressure reduced, temperature will get reduced. Now temperature got reduced, so boiling point will occur at the lower temperature. હવે એનું પ્રેશર રિડ્યુસ કર્યું 290 થી, સપોઝ એ થયું 70 ડિગ્રી સેલ્સિયસ પર એનું બોઇલિંગ સ્ટાર્ટ થઈ ગયું. ઓકે, સો બીકોઝ ઓફ ધીસ, આના લીધે એનું પ્રેશર ડાઉન થયું, ટેમ્પરેચર 70 સુધી આવી ગયું અને બોઇલ થવા માંડ્યું, એટલે એનું ડિકમ્પોઝિશન રોકાઈ જશે. એટલે હવે જેવું એ બોઇલ થશે, વેપર ફોર્મ થશે, વેપર અહીંયા જશે. હવે આ કન્ડેન્સર છે જેમાં વોટર ફ્લો થાય છે ઇન ઓપોઝિટ ડિરેક્શન. હવે પછી અહીંયા લિક્વિડ ફોર્મ થઈને અહીંયા રિસીવરમાં કલેક્ટ થશે. ફાઇન. ઓકે, નાઉ વોટ ઇઝ ધ એપ્લિકેશન? Prevent degradation of active constituent. That is, we have taken examples like 55 degrees Celsius. J 55 degrees Celsius per decompose થઈ જાય. Lower than that, we can use this vacuum like enzymes, vitamins, then glycosides, alkaloids. Okay. Now, second application is changing physical form. Now, we can here take an example. In the preparation of Cascara Sagrada tablets, granule extract is required. Okay, you don't require this powdered form. Sometimes powder don't get you can say compressed very easily, so granules are required. Now however, if you are drying it at its atmospheric pressure, that is 180 m or 760 mmHg, what happens is it forms a dense and compact residue. Okay, ekdam dense residue. What is the meaning of dense? Ekdam close residue would be there, which is not desirable. So this method is used in which initially pressure is partially reduced. થોડું ઓછું reduce કરવામાં આવે pressure. Okay, until the residue has the consistency of trickle. Now what is the meaning of trickle? Consistency becomes like a thick dark syrup. Okay, after that what will be there? Rapidly we will reduce the pressure. So when we reduce the pressure rapidly, the mass of the trickle, okay, will get swell. Okay, it will get swell. Now why it will get swollen up? Because vapor will be developing and it will pass from the liquid phase to vapor phase. Okay, so when the vapor which is there in the syrup will pass, this produces a light porous mass which can readily pass through a sieve to form granule powder. ઓકે, શું થયું? ગ્રેન્યુલ પાવડરની જરૂર છે. એટમોસ્ફેરિક પ્રેશર અપ્લાય કરશો તો એક બહુ થિક અને ડેમ્પ માસ બને છે. તો આપણે શું કરીએ છીએ? આપણે એનું પ્રેશર પહેલાં થોડું ઓછું કરીએ છીએ. તો એના લીધે શું થાય છે? એક કન્સિસ્ટન્સી સિરપ જેવી મળે છે. તો સિરપની અંદર ઓફકોર્સ લિક્વિડી માસ થયું એટલે એક વેપર હોવાનું, વોટર વેપર હોવાની અંદર. સો વોટ વી આર ડુઈંગ, દેન વી આર સડનલી રિડ્યુસિંગ ધ પ્રેશર. તો આપણે એકદમ સડન રિડ્યુસ પ્રેશર કરી દઈશું તો વોટ વિલ હેપન? ધ વોટર વેપર વિચ ઇઝ ધેર ઇન ધ સિરપ વિલ કમ આઉટ. Okay, when it will come out and it will get swollen up, એ ફૂલી જશે. એના લીધે શું થશે? It will form a light porous mass. Now what is the meaning of porous? Porous means a light mass, you can say. Porous in the sense there would be like space, void space would be there. That is known as porous, having large void spaces. Okay, which is essential for granule. Disadvantage: vacuum distillation forms foaming. Persistent foaming is there. To prevent that, capryl alcohol is added to the liquid, or by inserting a fine air capillary tube in the second neck of the cleansing flask will reduce that. Okay, so it is not suitable for preparing semi-solid or solid extract by distillation under vacuum.